All right, so first we're going to look at how quadratic functions can be used to model areas. We've got, in this example, a company offers rectangular pool sizes with dimensions as shown. So the dimensions of the pool right here, we've got our width of x and a length that is 2 times x, so it's twice as long as the width. So when they give you options, when this company gives you options for your sizes of your pool, they're saying whatever your width is, the length will be twice as long, and that's the shape of the pool that they offer. If Carolina wants a 15-foot wide pool, so we know that we want this to be 15 feet wide, how many square feet will she need to have available in her yard? So she's got to make sure in her yard she has enough space for the pool and for the surrounding deck. So what would that total area be? So that's what we're going to figure out, and we're going to show how a quadratic function can model that area. So part A, write a quadratic function to represent the area of the pool and the deck. So why don't we just keep in mind, we know area is equal to length times width. All right, so we're going to let f of x represent our area. If we look at the pool, the length goes from here all the way to here because it's the pool and the deck. So we know that the pool is 2x units long, but then we're adding on 4 feet on the left and we're adding on 4 feet on the right. So that total length is the 2x of the pool plus 8 total feet of decking, 4 feet on either side. So we're going to write in our length is 2x plus 8. So that's representing the length. We're going to multiply that by the width. Now this is the width of the whole thing, the pool and the deck. So from here all the way to here. Well, the width is the width of the pool is x units long, and then we're going to add on 4 feet of decking above and 4 feet of decking below. So the width is x units for the pool plus 8 feet for the deck. So x plus 8 will fill in for the width. All right, so we're going to go ahead and multiply this out. So we have our quadratic function that will represent the area of the pool and the deck. So we've done this before, multiplying this out. You're just going to distribute the 2x. So 2x times x is 2x squared. 2x times 8 is a positive 16x. Now we're going to distribute the 8. 8 times x is 8x. 8 times 8 is 64. So our function, our quadratic function, we know it's quadratic because of the x squared. To represent the area of the pool is 2x squared plus, oh, we have some like terms. 16x plus 8x is going to give us 24x. So plus 24x plus 64. So that answers part A. This function can be used to find the area of any pool, any rectangular pool that has that 4 feet of deck on either side. All right, so part B, find the area of the pool and the deck. So what they're asking for here is Carolina's pool. We know that she wants the width of her pool to be 15 feet. So we're going to let x equal 15. That's if you look at the picture of your pool, that's the width of the pool is x, and then we're going to use our function to figure out what this will be. So our function is area, so we're going to find the area of a pool that is 15 feet wide, so f of 15 equals, we're just going to take that 15 and plug it in for all the x's. We're going to have 2 times 15 squared plus, again, we came up with our function up here. We can use this to find the total area of a pool plus deck for any width of pool. And so we're using a width of 15. So 2 times 15 squared plus 24 times 15 plus 64. Notice I wrote that in with parentheses. I didn't forget to write in the squared. Now I can take my calculator and very carefully type that in. When you do, you should get back an 874. So what that tells us is that Carolina needs 874 feet squared, that's the area she needs, to build a 15-foot wide pool with a deck. And this company offers that 4-feet deck. Okay. Suppose the length of the pool in example 1 is 3 times the width. How does the function that represents the combined area of the pool and the deck change? Go ahead and explain. So if we were to redraw this picture, all that they're saying is the width is still x, but now the length is 3 times the width. So our length is going to be 3x, where before it was a 2x. We still are going to have the decking going around 4 feet beyond each side of the pool. So our area, f of x, equals, if we figure out what is the new length, well, the pool is 3x, plus we've got 4 feet of decking and 4 feet of decking, so plus 8. So 3x plus 8. And then the other dimension, we know that the width of our pool is x plus the 4 feet plus the 4 feet, so we have x plus 8. So if you look at the work you did before, you had a 2x plus 8 instead of a 3x plus 8. So how does the function, how does it change? That's the change. And then we will go ahead and multiply this out just to see what our new function would be. Distribute the 3x. 3x times x is 3x squared. 3x times 8, 24x. 8 times x, 8 times 8. And then f of x equals 3x squared, combine like terms, plus 32x, plus 64. So this is the quadratic function that would represent the area of a different size pool where now the length is 3 times as long as the width.